Hi all, good evening. Today we have the fourth uh, training session of K-12 Signal House project by IEEE Kerala chapter. And today's session, we have Mr. Karthik K, uh, Vice Chair, IEEE Kerala YP, and a engineer at Litmus 7 as our speaker for the session. So I welcome Karthik Devan to handle the session.
Thank you, Govind. Hope I'm audible.
Yes, you are.
Okay. Hey, everyone. Good evening. So, as Govind mentioned, we are actually in the fourth training session on the K-12 project. So, today we are actually going to discuss about the AI ML aspects of the project. And before getting into that, I'll give an introduction about AI and the domains and what are the real world applications of AI and so on. And after giving an introduction about AI and its derivatives, we are going to see what are we going to do for the K-12 project and how we can actually contribute to that. And also, like, I would like to mention that if we are actually going to say be a part of the AI domain, and if we are going to help in the AI domain for the project, I assume that you will get an hands-on experience how AI is working in the signal processing domain, and also how we can develop an AI application in the industrial standard. So that is what we are anticipating within the project. So without much further delay, let's start the session. I'm going to share my slides. Hope my screen is visible.
Yes, it's visible.
Is it on full screen right now?
Yes.
Fine. So introduction to artificial intelligence. So I actually started contributing and studying AI from my second year of BTech. But at that time, like the initial thing that I came to the mind while I heard AI for the first time was a robot walking off its own and doing or interacting with the human or the real world environment. So that's what my thought process was at that time. And I believe that most of the people has the same thought process like I does while hearing AI for the first time. So what is actually artificial intelligence? As the definition says, it's an area of computer science that emphasizes the creation of intelligent machine that works and react like humans. I need to highlight that part once again, which is works and react like humans. That is the core aspect of artificial intelligence. We are creating machines, whether it's in hardware or a software. We are making that machines capable of taking decisions and reacting to the real world queries like humans. So that is what AI does in a nutshell. So machines which can actually take sensible decisions like humans without any external supervision. I need to highlight the external supervision part also. If we are creating an AI machine, whether it's a hardware or software again, it is said to be intelligent if that machine is able to perform decisions without any external supervision. So that is what we can say, or with that 2 points, we can say that that is AI in the definition aspect. So what is AI? Is it a science or technology or subject, or is computers AI, or are computers only AI? So let's get into all of these answers in the coming slides. So where it actually start? I hope that you might know the guy who is on the left side, right side of the screen, which is Alan Turing. He was the founder of Turing test. I hope you might have studied what is Turing test in the school time itself. So I'll brush that for you guys. So Turing test will be there will be a computer as well as a human, and there will be a moderator also, and the moderator will be asking certain questions as a part of the test to the computer as well as the human. And at a particular point, if the moderator is finding it difficult to distinguish between the interrogator as well as the human as well as the computer, we can say that the computer actually passed the Turing test. So that is what, or that is, we can say that it's kind of the beginning of AI era. And if you are looking into the starting phase of AI, you can see its budding stages in the early white papers of 19th century. Okay, so that papers got derived into the form that you are seeing right now, as in the form of image recognition, image classification, natural language processing, and so on. So all these things actually started in the 19th century itself. You can see that in the that is clearly mentioned in the white papers of 19th century. And if I'm taking Turing test here as an example, I'll say that it's a basic foundation of a neural network that is seen right now in the daily life, which every one of us is using as a part of some applications or some games and so on. So that is actually the generative adversarial networks, or known as the GAN models. I hope you are actually familiar with that model, because there are certain applications which work on generative adversarial networks, like Face app, or the app that makes us old, young, etc., and changes our face to girl's face or boy's face and so on. So that is actually a part of the initial phases of AI. And Turing test, I can say that it's the model is actually we got an inspiration from that model at that time. I will say like that. So the major topics of AI that we are going to cover today is prediction, classification, knowledge representation, and the natural language processing, interacting with environment and expert system. We are going to see the basic aspect or the definition of each of them in a brisk manner. So what is classification or what is prediction? I'll explain that with a simple concept that we can relate in the daily life. So I'm going to give you a word, or I'm going to say a word which you might have forgotten right now, but it was a sensation 2 years back, or 1 year back, COVID-19, right? So at the time of COVID, if just imagine that you guys all are data scientists or AI engineers, and you had a habit of collecting the COVID cases of your locality for a certain period of time, say 1 month or 5 months, or say 1 year or something like that. You have the data of that much records with you right now. And since you are an AI engineer, you got an idea that say there is a pattern in the count that is happening here. I think I'll do some mathematical analysis and see the likely amount of prediction or likely amount of COVID cases in the next coming day, or for the next week, or for the next month, or say for the next 2 months. So that kind of problems are actually known as the prediction problem. And coming into the classification aspect, the name itself signifies what that actually is. Even then also, like I'll give an example. If you have, say, I can actually give an example here. Okay, so I'm giving an example as you have jackfruit with you, and you have coconut with you, or mango with you, chakka and manga. So how do you classify chakka and manga with artificial intelligence? So that's an interesting topic or interesting question to classify. If you're a human, how will you do that? There are n number of aspects that you can use to classify a jackfruit or a mango if you're a human, right? Because you can use its size, shape, color, texture, etc. Because everything that I have said right now are the features which is making a jackfruit as well as a mango distinguishable, visually distinguishable. So how will you do that with the help of AI? Similar things that I have said right now can be used as a feature in the AI aspect also. So With the help of all these features, we are classifying whether it is a jackfruit or a mango. So that is how it is being done. And coming into the third one, which is the knowledge representation. So what is knowledge representation? It's a kind of a derived topic or an advanced topic in AI, where I'm taking another example here again. I'm taking myself as an example, which is Karthik as an entity and IEEE Kerala section as an entity. I can connect Karthik with IEEE Kerala section with a relation called vice chair of IEEE Kerala YP. That is the relation where I can connect Karthik with IEEE Kerala section. So similarly, you can explain or represent n number of knowledges within node relationship manner, which can be used for AI trainings, AI inferences, and also for foreseeing unknown inferences with the help of knowledge graphs. So that is how knowledge representation actually works. Then coming into natural language processing. So natural language processing, I am taking another example here. I'm taking an example of a voice assistant, whether it may be Siri or Google Assistant or Cortana or anything. What you are doing here, you are giving a simple instruction that can be performed by that voice assistant, and you will get a reply for your response or your query that is given to the model. So what is happening in between? You are asking in English or you are asking in some other language. That language gets converted to a machine understandable language. That machine understandable language actually looks for the answer or the likely answer that can be given to the user in the domain or the knowledge base. That gets retrieved and it gets converted into the human understandable form. That is what happening. So this entire procedure is actually known as a natural language processing problem. The next one is interacting with environment. Here I'm taking speech recognition as an example initially. So I'm taking the example of the chatbot again or the voice assistant again. Here we are not typing anything. Instead, we are actually going to speak with that voice assistant, and that speech will get converted into text. Text again gets converted into the computer understandable form. Same process happen, and you will get again a reply as a text, and that gets converted into the voice again. So that is what speech recognition does. Also, I'll give another example. If you can log something with the help of your voice, and if you can unlock it with only your voice, that can be considered as a personalized speech recognition engine, where you can use only your voice to control that machine. Then we have computer vision. So computer vision is simply how computers or intelligent machine actually sees the human world. The last one is expert system. So expert system again is a derived or the advanced versions of machine learning, where you can use that system to get something out of it meaningfully in the part of a domain. So I'll say that ChatGPT as an example here. So ChatGPT is a really good example of an expert system in terms of reasoning. Reasoning, you can actually use ChatGPT to get an answer. Okay, so similarly, there are so many expert systems that you can use to get an answer domain specifically. Okay, so that are the main topics that we are going to cover in today's session. This actually shows the subset of artificial intelligence. If you take any of the domain that you have here, which which actually aligned with AI, we can say that all of them are actually subset of AI, or AI is the superset of all the domains that you hear right now. We have machine learning, NLP, speech, expert system, planning, scheduling, and optimization, robotics, vision, etc. Then that again further divided into deep learning, predictive analytics, translation, classification and clustering, information extraction, speech to text, text to speech, image recognition, machine vision, etc. So we'll get to know about all these things one by one. Initially, I'm taking machine learning as an example. If you have some data with you, and if you can generalize that data from input and output, while you get an input, you get an output with the help of a statistical analysis or a statistical equation, we can say that it's a machine learning problem. So how machines actually learn with statistics? It's simple. How many of you know that y is equal to mx plus c corresponds to a machine learning problem statement, which is the baseline of n number of sophisticated models in machine learning? Okay, so how does that gives you a light? So y is equal to mx plus c, where there is a y factor, x factor, m factor, and a c factor, where y is your output, x will be your input, m will be your, say, if I'm taking that as an example of a straight line, m will be your slope and c will be the constant value. Where if you know the m and c values of your domain, say you have n number of numbers with you, and if you know the value for m and c for that domain, if you put any value on x, you will get the corresponding y. So that is how you can optimize your domain knowledge or your domain values to what you want to know with the help of the statistical analysis. So that is how machine learning actually works. Simply, y is equal to mx plus c can be transformed into next level for a machine learning equation. It is also the baseline model for n number of sophisticated models like time series prediction models such as LSTMs or RNNs or anything that is seen right now. Furthermore, if we are dividing machine learning again to the subsidiary sets, we have deep learning and predictive analytics. So what is deep learning or what is predictive analytics? Deep learning, the name itself signifies what is deep learning, because something that is not been able to achievable by a machine learning model. We are using deep learning for that. So machine learning is not enough for some in some cases. So we are using deep learning in that cases. We'll get to know about more in the coming slides. Predictive analytics is nothing but the prediction aspect that we have seen right now. Natural language processing also we have seen. We are going to see its subdivision, which is translation, classification, clustering, and information extraction. So what is translation? I'm taking that again in the perspective of natural language processing because I have added those three as the subset of natural language processing. So what is translation? So you might have used or you might have been using right now also so many translators in your daily life, like Google Translate or any, so there are so many dictionary which has the translation also. So what is happening there? You are saying that in one language, you are getting output in another language. So similarly, that again gets converted to the machine language that will look for the alternative option in the another language in the machine language itself. Then it gets converted to the human readable form. So that is what happening in translation. So similarly, you can consider that as a subset of or a subdivision of natural language processing. When we have classification and clustering, for that also I'll take an example. You have a data set with you where you have recorded some text as well as its emotions, say happy, sad, or anger, or something like that. And if you can classify that with an example of a machine learning classifier, we can say that it's a classification example. Taking that data set again and removing the labels such as happy, sad, and anger, and taking the text only with us, if we are able to say cluster that into three, which is happy, sad, and anger again, we can say that it's a clustering algorithm or a clustering aspect in natural language processing. Lastly, or in this, we have the last as information extraction. So what information extraction actually does? Information extraction is simply but all the process underlying in the natural language processing goes through information extraction at least once to fetch the information at the right moment of time and at the right quantity. Then we have speech. Speech, we have speech to text as well as text to speech, as itself the name signifies what actually it does. Expert system we have already seen. Planning, scheduling, and optimization. That is another thing we have to look into. So I have read in an article that Japan actually uses an AI travel planning app, which you can use to book and plan your travel. So if you are a user of that in a frequent manner, say after n number of iterations, if you're going or if you are planning to visit some places, the hotel that you have booked will welcome you with the your favorite welcome drink at that time. And you will get to have the customized packages and where you wish to go and how much you can actually spend on your vacation and so on. So that actually comes with the planning, scheduling, and optimization aspect of AI. And the next one will be robotics. Initially, I told that once I heard the word AI for the first time, the thing that I got into my mind was robot walking off its own and interacting with the human environment. So we can say that AI itself is a part of robotics, where the software part of the robotics is being controlled by AI. Then we have vision, where we have image recognition and machine vision. So image recognition is a really simple use case or a generic use case that every one of us can be related into. How? So simply we are using smartphones and in that we are using face lock. So face lock itself is an example of an image recognition problem statement. And machine vision is nothing but how machines are actually seeing and reacting to the human world. AI versus machine learning versus deep learning. I initially told that the advent of AI actually started from the 19th century itself. You can search that in the 19th century by purpose to get the intelligent aspects of machine learning, AI, etc., to get the basics in that time frame itself. When it actually got evolved into the statistical analysis, which is called as the machine learning statements. Again, with the advent of good amount of data as well as computational technology, it again got say developed into deep learning, and certain breakthroughs happened within deep learning. Also, I would like to mention something in this slide. I've been seeing lots of sessions happening about machine learning, AI, and deep learnings and all. But everywhere I go, what I get is training a neural network and doing that in an MNIST classification problem statement. But that's not actually good, or that's not the proper way. So if you are actually going to hear or know about AI, all these things that I am saying right now has to be addressed. How the approaches is being validated, what are the different types of AI domain, and how say all domains are actually interconnected and so on. So these all things you have to know if you are actually going for an AI session. If you are hearing in a or if you are going to get into a machine learning session, you need to know that you need to understand about the statistical analysis, you need to know about how the data is being cleaned or how a new prediction is happening, etc. You have to get to know about in machine learning. If you are going to sit into a deep learning session, you need to know about or you need to get from that session like the classification, the image classification, or say recognition aspects or detection, etc. You have to get from a deep learning session. So don't get fooled by getting into the names while you see a session. Analyze that what you want to get from the session and see if you are getting properly from that. And you can complain also, like if you are not getting in a the predefined manner of these topics. So we are getting into the topic or the next topic, which is what is machine learning. So as I told initially, it's something that we have to do with statistics, or it's a statistical modeling perspective of AI, where you have or you can use statistical models to give the computers to learn and to get to know more about the data. The basic premises of AI the basic premises of machine learning is to build algorithms that can receive input data and use a statistical analysis to predict an output and update outputs as a new data becomes available. I'm highlighting that portion, which is updating outputs as the new data becomes available. Why? Because that is the important aspect. If you have built an analytical model or a statistical model, and if you are capable of predicting it, we can say that it's a good model. Unless and until if you are getting a data from the same domain which hasn't been which haven't been going to the training aspect, and but you are using that for the prediction, and still you are getting a correct prediction or likely to be a great prediction, we can say that it's a good model or it's a better model. So that is how a machine learning premises actually work. And coming to the third point, that is the standard definition of ML where you are studying ML in your elective or as a subject or anything in your college, which is a computer program is said to learn from experience E with respect to some class of task T and performance measure P. If its performance at task in P as measured by P improves with an experience E. So I'll say that I have, say, from, if I'm counting it from my academical period, I have around 7 to 8 years of experience in AI, and still I'm not able to by heart that definition properly, because it's something that not I'm not getting that in my mind. So if you want to get mark, or if you getting that question in your examination, you might have to by heart it and just state it in that manner itself. So that's about the standard definition. And coming to the last and the most important point, which is data is the new oil. So why data is mapped to oil? We all know that oil is highly inflammable as well as oil is really expensive. Similarly, data is also highly inflammable and really expensive. If there was actually an interesting survey which states that if there is going to be a next world war, it is going to be for the data. That is why big tech companies like WhatsApp or Meta or Google or any company that you are seeing right now is hungry for your personal data. Why? Because if they have your personal data, the predictions or the the output that you are getting or the outcome that you are getting out of all these services will become really personalized, and you are becoming a slave, or you are getting addicted to that platform because you are getting personalized information. Machine learning process. We are actually seeing there 5 steps, but I'll add one more step, which is the 0 step. And this is what I usually used to get from BTech students right now, which is I need to do an ML project for my final year project or for my mini project and so on. But I don't know how it can be done. Or my staff advisor or my teacher actually advised me to do this project with the help of AI because AI is trending. So my 0 point will be identify whether this problem statement requires machine learning or AI aspects or not. That will be the 0th and important point. If it requires AI only, go for the further step, or else leave it from the 0th step itself. You can use or complete with the help of simple programming language and just complete that task itself at that time. First point will be identify the relevant data set and prepare them for the analysis. It's not the model that is built initially. We have to see and look into the data initially. If we don't have the data, we have to prepare it, we have to process it, and then only with the help of that data, the model is being trained. Second one will be choose the type of the machine learning algorithm to use. That is another important aspect. There is again a saying in AI, which is for every problem statement in the world, there is an aligned machine learning solution to it. That's one way or another way is right. So we have to choose the right algorithm at the right time, and that is how a good engineer actually works. You can say if you can solve a problem using n number of machine learning solutions, that's okay. But a good machine learning engineer or a good engineer will always try to solve a machine learning problem or any problem with minimalistic computational capability, minimalistic time complexity, and higher efficiency. That is how a good engineer actually works. So that's how you should be actually. Then third one will be build an analytical model based on the choose an algorithm. That is the third point. You have your data which is processed with you right now. You have your model also with you right now. The third one will be to make that data and algorithm to combine together to form a model. And fourth one will be training that model to see how it is actually performing. And fifth one will be running the model to generate scores and other findings, or deployment of your AI model, just like the useless AI cameras that you are seeing in the Kerala roads right now. Okay, I don't know how much accurate and efficient that can actually work into. We can see and experience about that in the coming days. I don't know how much efficient it can actually go into, because you are really going to deal with Kerala people as well as Kerala roads. It's not America or Gulf countries to be systematic. It's Kerala. So types of machine learning. We have supervised learning, unsupervised learning, and reinforcement learning as the basic divisions of machine learning. So we are going to see all of them in a detailed manner. So I'm taking an example of a baby here, and that baby actually starting to study about the random facts, like writing from 1 to 10, or writing from A to Z, or anything. So that baby is ready to study from their parents or something like that. So the parent is showing the baby how to write 1, how to write 2, how to write 3, and so on. So the baby understands something. Now the baby is trying to write from 1 to 10 without anyone's help. So since it is the baby's first time, there is a chance of getting an error for that baby. At that time, the person or the parent will intervene and tell the baby that, hey, it's not how it is written. You have to write it like this. So there is a supervision that is given to that baby at the time of learning. So similarly, if you are putting that in the perspective of machine learning, we can say that it's a supervised learning, where you have your data, you have your label, you are making the algorithm study the data as well as the label, and while a new data comes, it actually matches with the label and see how the prediction actually goes. So that is what supervised learning does for you. Next one is unsupervised learning. Here I'm taking the example of baby again, and in this baby we don't have, the parent is not there, but the baby actually understand something about the world, and he or she is actually trying to study from the media that is allowed to see by the baby, like maybe it will be TV or some books or something like that. So from that the baby starts to learn. But here the error factor that I mentioned in the previous example will be higher, because there is no supervision that is happening for that baby, and the baby is trying all of its own. That is why we usually say that supervised learning is more accurate than unsupervised learning. Then you might have thinking, yeah. So you might be thinking that why we need to use unsupervised learning. So there is another catch which is related with the myth of data in the world, because the number of data or the amount of the data that we have right now is like the amount of water that is there in the world. And to put that in the perspective, out of the 75% of the total water that we have, there is only a less amount of or less percentage of water that you can actually use to for your own purposes or your personalized purposes. But are we not using the rest of the percentage for any other purposes? Certainly not. We can use that by proper, say, for example, if you want to make that drinkable water, we can use that with the help of proper facilities and all, proper filtration and all. We can make it as a drinkable water. So similarly, there are n number of data points, or there was again a survey stating that petabytes of data is being produced every day. So in that also a few percentage is being used. That percentage can be used with the help of such a unsupervised manner and make it into a really reliable data and use it again for another further divisions and all. Now coming into the reinforcement learning. Here we have again the parent as well as the child, but here the parent is new generation. Say the parent is going to give a chocolate to the baby if he or she writes from 1 to 10 without any error. So for getting that chocolate, the baby tries to write from 1 to 10 without any error. So if you are putting that into a machine learning perspective, we can say that that's the reinforcement learning procedure, where we are related with an agents and environments, where environment will try to be as smart as possible with the help of the agent available with associated with that environment. So that is how reinforcement learning actually work. So this is something that I found very interesting in internet recently. So what others are thinking about how machine learning engineer work. So at the end of the day, it's something like what I really do in the sixth finish. But there are other aspects also, because for every engineering job, or so sorry, like for any job that you are doing, there is two aspects of that job, which is an engineering perspective as well as a research and development perspective. That is for every job that you have, that is there in this world right now. So if it is an engineering perspective, you don't have to be much vigilant or much cautious. You need to be a really good problem solver, and you need to be a really efficient engineer only. But if you are going for that research and development perspective, that is the place where you are using your true potential, where you need to define your own equations, you need to define your own laws, and you have to build your own algorithm for doing that. Big data and machine learning. With the advent of big data, it gave us the power to train complex models. That is how the deep learning terminology has been active in the world right now. So we are going into deep learning. Mimicking the human brain, neural networks, GPU, too much amount of data, auto feature selection. These are some of the things that I am getting into my mind while I hear deep learning. So here also I'm going to highlight the last point, which is auto feature selection here. Why? Because machine learning doesn't have a feature for auto feature selection where we are specifying the features to the statistical analysis. But in the deep learning, you don't need to specify the feature. Instead, you need to give the proper data only. The features will be extracted by the models itself. Neural networks, a method of computing based a method of computing based on the interaction of multiple connected processing elements. Ability to deal with incomplete information. Powerful technique that can solve many real world problems. Ability to learn from the experience and improve their capability within the performance. So these are some of the things that you should know about neural network, and you can use also that for your exams and all. Topology of neural networks. These are some of the topologies of the very common neural networks that you are seeing in the real world right now. And also don't get fascinated with all these circles and the connectors, because it's not easy as it looks, or it's really complex when it goes to the, say, the bottom part of this image itself. In the topmost part, you can see symbol algorithms, and to the last parts are all like Markov chain models or Hopfield networks, Boltzmann machine, restricted Boltzmann machine, capsule networks, etc. So these are some of the very complex models that is right now readily available as the base models. How does this magic actually works? Here you can see an example of a cat and a dog, where the dog's image is being passed into the this circles and connectors, and the output is also being predicted as a dog. So how does this actually work? I hope most of the people has the same kind of confusion as also, because you are seeing so many circles, you are seeing so many connectors, and you are passing an image to that, and you are getting the right output, which is the dog. So how does this happen? So to put that into perspective, we need to learn about the layers of machine learning or layers of neural network, which is input layer, hidden layer, and output layer. These have certain functions where that is why you are getting these things available for you as say cat or a dog. So how it is like, we have an input layer where we are passing the processed image. So what is an image? Again, I'm asking a question. So image is nothing but the collection of R and G and B metrics or pixels. So again, if you're taking that matrix, you have individual pixels. So we are processing that image and passing that to the input layer. Then the input layer's facility or function is actually to get that from the user and pass that to the hidden layer. So hidden layer need not be one layer. It may be 2 layer, 3 layer, n layers. So what is the purpose of hidden layer? So hidden layer is the place where the actual factory setting happen. Because taking the example of cat and dog, or taking the another example that I have said in the initial phase, which is the Chaka and Manga classification problem statement, you can use all these layers as a factory unit where it processes the texture, color, size, shape, etc. So that is the functionality of a hidden layer. And coming into the output layer or the last layer, where the hidden layer might have given some score to all the input that is being given right now, or the processed inputs that is there in the hidden layer. With the help of all these scores, there is a probabilistic model that is working on the output layer to find that whether it is a cat or dog. So if the probability, say, if it is the probability which is getting high for the first class, we can say that it's a dog, or if it is for the 0th class, we can say that it's a cat. So that is how this magic actually works inside a neural network. It's a mathematical explanation or mathematical working animation of the neural network again. Math behind AI. So I've been interacting with several students from several part of the world, and why the major thing that I hear about AI is I'm not getting into AI because I hate mathematics. Trust me, if you are really good till you are 12th in mathematics, that is okay. Or even your 10th is also okay. If you are really good at 10th or 12th in your mathematics, that is absolutely fine to crack a simple and basic ML interview. Okay. Rest of the things you will get from the work experience. Applications, some of the applications we are going to see right now. Object detection is an application. Activity recognition again is an application. Semantic segmentation is an application. Image colorization is an application. Photorealistic style transfer is an application. Again, an example of GAN model. Background removal is an application. Object removal is an application. Another example of GAN models. Image completion is an example. That's also another example of GAN model. Lip sync from audio. Fake apps or deep fakes, etc. Generating images by GANs. GANs evolution. Multi-domain image-to-image translations. Unsupervised image-to-image translations, etc. So these are some of the real-world applications that we are using right now in AI or in deep learning aspects. Programming languages for AI. So basically, we can use all these programming languages to code AI. Why Python is being prominent is because Python's developer support is really high. That is why everyone is using Python. And also, you can write code as you are writing a story. So that is why Python is really simple and easy to use. I know people who used to code on C, C++ and all for machine learning, where there are critical time constraints, because Python is not that much fast when compared to the computational timing. But C, C++ are working in lightning speed. So many cases where I have seen, say, C and C++ being used in big tech companies and all. Some of the tools that you can use for coding AI, TensorFlow or PyTorch or Kotlin, you can actually Keras and all you can use for coding deep learning algorithms, where scikit-learn can be used for, say, machine learning algorithm. OpenCV or say PIL or skimage can be used for image. Computer vision algorithms and image processing algorithms, NLTK, SPACY, etc. can be used for natural language processing algorithms. And Anaconda prompt or Jupyter Notebook, Google Colab or Kaggle is some of the places where you can use to code your AI algorithms. Learning platforms for AI. There are n number of learning platforms that you can use, and if you don't want to get a certification or you don't want to pay for a course, I would recommend you to find some really good YouTube playlist and study from that. Advantages of AI. The efficiency of labor resources will be increased. Faster information processing. Reduction of errors. No influence on personal connections will be there. Then personalization information will be really high. Exploration capability. So these are some of the basic advantages of AI. Disadvantages: lack of knowledge about the foundation of AI, misuse of AI, no data, no power, computational limitation, and threat to humankind. So The threat to humankind, I'm not emphasizing that right now because we can say that in the 20th century, in the coming centuries, we can look into it and see if it is becoming a threat to humankind. So that's it about the session. Prepare for an AI era. And coming into the K-12 perspective, I'm just taking some examples here, which is automatic speech recognition and brain signal analysis, as well as emotion recognition. So these are some of the things that I am planning to do as a part of this K-12 project. So if you are the part of this team, and if you want to collaborate to any of these projects, do let me know. I actually need help because I'm doing that as a one-man army right now. So if anyone wish to study and if anyone has a passion and if anyone is a self-learner here, please reach out to me. I'll give you the needed training for that and we can work it out together. So that's it from my side. I'm just stopping the screen share right now for QA. If there is any questions, we can clarify that right now and we can wind up the session after that.
Thank you, കാർത്തികേട്ട. ബിഫോർ ക്യുഎയുടെ കൂടെ തന്നെ നമുക്ക് വേറൊരു കാര്യം പറയാനുള്ളത്, നമുക്ക് ഈ പ്രോജക്റ്റിന്റെ ചേട്ടൻ ലാസ്റ്റ് പറഞ്ഞ കാര്യമാണ്. അതായത് നിങ്ങൾക്ക് ആർക്കെങ്കിലും ഇപ്പം ബേസിക് ആയിട്ടുള്ളൊരു നോളജ് ഉണ്ട് എങ്കിൽ ആൻഡ് ഇഫ് യു ആർ ഇൻട്രസ്റ്റഡ്, നമുക്ക് നെക്സ്റ്റ് വീക്ക് ആണ്. അപ്പൊ നമുക്ക് കുറെ അധികം കാര്യങ്ങൾ ചെയ്യാനുണ്ട്. സോ നിങ്ങളുടെ സപ്പോർട്ട്, അതായത് ഇവിടെ ആരും നമ്മളെ ഫോഴ്സ് ചെയ്യുന്നില്ല, ബട്ട് നിങ്ങൾ തന്നെ ആ ഒരു ഇനീഷ്യേറ്റീവ് എടുത്ത് മുമ്പോട്ട് വരുവാണെങ്കിൽ ഇറ്റ് വിൽ ബി ഗ്രേറ്റ്.
So if you have any queries, you can reach out to me. Also, you can reach out to me on LinkedIn. Like I'm really active at LinkedIn. You can just search for Karthik K or Karthik K space IEEE or something like that. You'll get my profile in one go itself. So that's it from my side, and thank you.
So anyone, any questions? Otherwise, we can wind up.
I guess we can wind up going.
Yeah. So thank you once again, Dr. Geta. So Naima, we can wind up.
Thank you.
Okay.